Okay, so welcome to the last video for day 4 notes. We are going to be doing reaction stoich using molarity. Yay! Stoichiometry! Okay, so because molarity involves moles, we can use molarity for stoich problems. So molarity can be calculated by finding moles using stoichiometry, then dividing it by liters, or it can be used as a conversion factor. Because, reminder, the unit for molarity, while it is capital M is the same as moles per liter. So we can use molarity as a conversion, just like we would molar mass, density, 22.4 moles per liter for our gases. Okay, we can use molarity as a conversion. That means, since we can use it as a conversion, molarity is never our given value that we are starting with. You never, never, never start your stoich problem with molarity. Okay? You will use molarity as a conversion. You will not start for molarity. Or you can solve for molarity with 2 steps, solving for moles, and then in a separate step, dividing by liters using molarity formula. Okay? So let's do this first example. How many milliliters of a 0.150 molar potassium iodide solution would be required to react completely with 15 grams of lead 2 nitrate? So we're doing a stoich problem. What do we always have to do with stoich? What's the first thing that we should write down? Our balanced equation. So we have potassium iodide reacting with lead 2 nitrate. What is potassium iodide? Ki. What is lead 2 nitrate? PbNO3 2. And then what are your products going to be? So if we start with K, it's going to be K what? Okay, NO3 plus what? PBI2. Okay. Is this balanced? No. What can we do to balance it? Good. 2Ki, 2KNO3. All right. So it asks us to solve for milliliters. We're given molarity and we're given grams. What's going to be our given? Grams. So we're going to have our given as grams. That's what we're going to start with. So we'll start with 15 grams of lead 2 nitrate. Okay. What are we going to do next? Yeah, good. Molar mass. So just for time's sake, I'm going to give you the molar mass, but please make sure that you stay up to date and remember how to calculate molar mass. Because remember, last time I did this, some of us forgot how to calculate molar mass and got a lot of that wrong. So, your molar mass for lead 2 nitrate is 331.22 grams. And then 1 mole. Okay, what are we going to do after this? Yeah, we're going to do our mole ratio. So it's going to go on the bottom. 1 mole lead nitrate And what's on top? Good, 2 mole Ki. All right. Now we're in moles of potassium iodide. So we're now in with the substance that we are trying to solve for. We're asked to solve for what? Milliliters. Okay? So we've got moles. We're in moles. We're given molarity, and we're asked to solve for milliliters. What do you think we're going to do next? We're going to use our molarity as our conversion. What is that going to look like?
1 mole Ki on the bottom.
Not quite. Yeah, so liters will be on top, moles will be on bottom. What value is going to go with our moles? 0.150. So this is like density or like molar mass, right? So your molarity, this M means moles per liter. So we can say 0.150 moles per liter. So your 0.150 goes with the unit it's paired with, that moles, and it will always be 1 liter on the other side. Yes? Okay. So then 0.150 mole Ki on the bottom, 1 liter Ki on the top. And it asks us to solve for liters? Milliliters. So I don't care if you use your 1e negative 3, if you use your 1000, does not matter, whichever one you prefer and are more comfortable with. I'm going to use 1000, so I'll set it up as 1 liter Ki on the bottom and 1000 milliliters Ki on the top. But if you did your 1e negative 3, then it would be 1 milliliter on top, 1e negative 3 liters on the bottom. Multiplying by 1000 is the same as dividing by 0.001. Okay, so then go ahead and solve. All right, so what is our final answer? 604 milliliters of potassium iodide. Awesome. All right, so next is this next example. All right, so this last problem says if 25 milliliters of hydrochloric acid with a concentration of 0.1234 molar is neutralized by 23.45 milliliters of calcium hydroxide, what's the concentration or the molarity of a calcium hydroxide base? First thing we have to do is write our balanced equation. So we're going to have hydrochloric acid plus calcium hydroxide, and it makes HOH plus calcium chloride. To balance it, you would do 2, 2. All right, so you're starting with milliliters. You have molarity, and you also have milliliters of calcium hydroxide. So you're given 3 things. You need to figure out what you're starting with. You cannot start with your molarity, okay? Your molarity is a conversion. But since you have the molarity of hydrochloric acid, we want to start with hydrochloric acid, especially since we're being asked to solve for calcium hydroxide. So we're going to start with our 25 milliliters of hydrochloric acid. So we can do okay, and then We need to change substances. The only way we can change substances is by being in moles. So we have to get from milliliters to moles. The way that we can do that is we can use our molarity. So we need to get from milliliters to liters, and then we can use the molarity to get from liters to moles. So we can say 1,000 milliliters is the same as 1 liter. And then we can use that molarity. So we can say 1 liter of hydrochloric acid and 0.1234 mole hydrochloric acid. So now we're in moles of hydrochloric acid. At this point, what can we do? Mole ratio. So we can go from moles of hydrochloric acid, so 2 mole HCl, and we're solving for calcium hydroxide, so 1 mole CaOH2. Oh, hold on. And then we're going to stop. So this is the end of our first step. Because we're solving for molarity, we cannot solve for molarity using just dimensional analysis, because molarity is moles divided by liters. So we'll go ahead and stop here and solve for moles. So whenever we do that, we're going to get 0.0015425 moles calcium hydroxide. I didn't really round here. You can, but I'm only 1 sig fig off, but I want to try and round as little as possible. Okay? Then I can just take this moles and plug it into a molarity formula. I'm solving for M. I have the moles. And then what is my volume? Perfect, 0.02345 liters. And then whenever you plug that in, you're going to get 0.06578 molar calcium hydroxide. Now, so I said that you could do this in 2 or 3 steps. This is the combined 2 steps. Okay? So 1, 2. You could also choose to do it in 3 steps by, instead of doing one long dimensional analysis, you break it up into molarity, mole ratio, molarity. So you can use your molarity formula. You've got your molarity and your volume, solve for N. From there, take this value, do your mole ratio to get moles of calcium hydroxide, and then you're going to go ahead and plug it into a molarity formula again, now calculating molarity of calcium hydroxide. So you can do it both ways. Both ways are totally fine. Both ways will get you full points. Does anyone have any questions? Yes. Hey, y'all. Shh.
I didn't convert it to like liters since both of them are milliliters. Can I just do that?
1 second. All right, so that is it for all of day 4, and that is the end of our solutions unit. So if you have any questions whatsoever, please go see your teacher for tutorials. You're welcome to stop by any one of us, okay? Otherwise, I hope y'all have a great day, and I will see y'all later. Bye.